So we'll just real quick go over what's due. So tomorrow, again, your laser cut part in that box. You could do it now if you want. Your quiz 4, which is your aluminum box. Your cube, which is due at the end of the day, 4:35-ish, let's say. And I'm going to collect homework 14, which I'm going to assign today. And that's a solid cam. You also need to watch the CNC bed mill video and watch solid cam video tutorials 3 and 4, which are complete the part programming and simulate the tool path and generate G-code. Any questions there? Okay. We were about a half a day to a day and a half behind. So normally today would have been open lab, no lecture for the third segment. And that way you could go into the shop and start machining your parts. When we catch up, a lot of next week will be open lab on the third segment and maybe even the second segment. So we may start only having one lecture or 2 lectures. And then you'll have a lot of open lab time during the 9 to 12 slot. So be prepared for that. So what I want to do is finish this drilling tool path, and then for your homework I'm going to assign you to create a cam part definition and create drilling tool paths for all the holes on the plate that you have clamped down. So there are a variety of holes in that plate, and there's more than one set, right? So you're going to have to write multiple drill tool paths for those holes. Okay, so let's finish this up. So where we left off, I had this drill tool path, and you now see it here. It's called D_drill with tool 1. Let's go back in and edit that. I stopped at technology. Let's finish our technology. Okay, now in drill bit paths, there isn't a lot to technology, but there is the drill cycle type. Right now, remember G codes, this is in G81. If you click the drill cycle type, you can see pictures kind of describing what they do. So G81 is drilling straight in there. G82 is drilling in there and then doing what's called dwelling, which is waiting, which is why it has the hourglass, and then coming out. G83 goes up and down, up and down, up and down. That's a peck. G73 is a different kind of peck. G84, this is supposed to be a picture of a tap. G84 peck is supposed to be a pecking tap, where it kind of goes in a little bit, comes back out, in and out. My controller doesn't support rigid tapping, so we don't have that. 85, 86, and 87 are boring cycles. All right. The ones you're going to use the most often are G81. That's where you just drill straight through and straight out. Or G83, which is a peck. I'm going to select peck, even though in this case the material was only about 78,000 stick. We probably could have gotten away with drilling all the way through, but I'm going to select a peck so I can show you the peck, which is what you were asking, right? All right, so I select a peck drill. Then you have to hit data, and your Q peck is how much you peck. So let's say we want to peck by 30 thousandths of an inch. Okay, that'll set it. Now, if solid cam will not show you the pecks, it'll just go and drill it. If you want to see the pecks graphically, you have to put in the same amount on step down, and then it will graphically show you on the computer. If you don't put it on step down, on the computer it's just going to show one hit, but on the machine it'll peck if you have that Q peck in there. Is that clear? So for right now I'm going to leave it 0. I'm going to hit OK. One more thing I want to check. On the bed type mills, they support G83, which is a canned cycle. It's like a subroutine of software. They support it. Wolf Creek does not. It does not. So if you want to peck G83 on Wolf Creek, you use G83 and you use the peck, but you uncheck use cycle. And what it's going to do is generate code that says, go to Z -03, come back to Z.1. Go to Z -06, come back. Go to here. So it'll write like 10 lines of code when the CAN cycle would have wrote 1 line of code. But it's because that controller doesn't support that cycle. So for if you're on Wolf Creek, uncheck use cycle. Questions there? All right. Let's go ahead and save and calculate. So this toolpath, it says depth is below the coordinate system lower level. Is that okay? The answer is yes. Remember, we asked it to drill farther than the bottom of the part. So yes, that is okay. We asked it to do that. All right. Now what you can do is you can use these other functions. This one's the coolest. Simulate. Again, it says your depth is below. I'm fine with that. Now you get this here. You have a lot of different options on simulate. Okay. You have HostCAD, 2D, 3D, Solid Verify, all this stuff. There's only 2 I really like to use, which is HostCAD, that's the default one, and Solid Verify, that's another one. I'll show it to you. You also have options here under HostCAD. Show the toolpath, show hidden lines, show the tool, show the trail. I'm going to hit show the tool 3D. I want to see that tool as it goes. You also have this tab called Data. This is very useful. I'll show that to you in a minute. But for right now, I'm going to just show you the way it goes right now. You also have a speed bar. You can play this or you can step it 1 step at a time. All right, let's go ahead and play it. There's my drill bit. It moved to all 4 holes. I'll slow it down. Play it again. So you've simulated it. Okay? This is a graphical interface for you to see if it looks the way you want it to look. All right, let me show you what data does for you. So if I hit show data, it's going to show me actual coordinates of where this tool is. Sometimes that's very useful. Okay? And in order to show this data properly, I'm going to go ahead and hit the step feature, not play it. So I'm going to step it 1 step at a time. Look what I'm at. I'm at X, Y, and I'm at Z 5 inches above the part. Now I step again, step again. Now I'm at a 1/2 inch above the part. That's where I set my safety distance for the second group, 1/2 inch above the part. I'm going to step again, and now I am at Z -1154. That's the 78 thousandths of the material plus the tip of the drill bit plus the delta that I put in there. And then I step again, comes out to 5, step again. If I zoom out, it's moved over here, step, step, step. So that data can be very useful for knowing exactly where that thing is, not just a graphical representation of it. So you might want to use that at some point, and that's right here in this button. You also might want to use Solid Verify. And what Solid Verify does is it shows you your actual stock and what your stock is going to look like after it's been drilled. So go ahead and hit play. And that's what my piece is going to look like after it's been drilled. So this simulation feature is very nice. Always simulate your toolpaths just to see if there's anything that looks out of the ordinary. Any questions on simulation? All right. The next step, we're done with our toolpath. It's sitting right here. We're happy with it. We're done with it. The next step is to generate the G-code. So you go to this G-code button and hit that button. Depth is below the coordinate system. Yes, and that's why it says don't ask again. I'm tired of hearing about that. And it generated G-code, which the machine can now understand. Okay? This is in the case of the bed type mills where I've got a G83, a CAN cycle. In your case, If we were to go back and uncheck use cycle, save and calculate, generate the G code, notice there's no G83 here. For every point that I wanted to drill to -1154, it actually made a set of 4 lines of code for every one of those. So here's your drilling right there, all those lines of code for Wolf Creek, because it doesn't support a canned cycle. Here's the code for a controller that does support a canned cycle. It's those 4 lines. This is what you need to save. You're going to file, save as. I'm going to put it on the desktop, but you would put it either on a floppy drive, which we have for Copper and Wolf Creek. I know that's old school, but it's just the way it is. And then Vail has a flash drive port for USBs. For Wolf Creek and Copper, we just upgraded this year to a floppy simulator, a USB floppy simulator. So it actually isn't a floppy drive, but you must use the little USB that we have. If you plug your personal little USB into Copper or Wolf Creek, it will not recognize the file system and it will format your drive. So all your work and your pictures and everything you got on your flash drive will be gone, formatted. See ya. Did everybody hear that?
Can we format beforehand and then put the files on?
Yes. If you want to use your own personal drive and format it just for those machines, go be my guest. I'm just warning you. I don't want you to burn all your data on your little flash drive. Okay? If you don't want to burn all the data on your little flash drive, use one of ours. We have 2. Okay? All right, so you need to save that onto the flash drive somewhere. And it is I haven't tested this with the controllers, but they were basically built on DOS operating systems. So they're only going to recognize about 6 characters. And then they're going to put a little tilde squiggly and a little 1. So if you want to recognize it as something that you recognize, name your files less than 6 characters. So I'm just going to say drill. How about drill 4 for 4 holes? Whatever, it doesn't matter. Save that file, get it onto that floppy drive, and then load it up on your machine. You can ask us for help on that. Okay? That's the whole life cycle of writing a CAM part definition and writing a toolpath. You now know how to write a drill toolpath. Questions there? All right? I'm going to show you one last thing, and I'm going to do it on the part that you have. So if you want to cheat and be a cheater, watch. We're going to go a little Tom Brady up in here.
You're bragging on them a lot lately.
It's Denver, dude. We can't stand the freaking Patriots. Screw those guys. I'm trying to see if this is the part that you're working on. Yes, this is the part you're working on. And if you'll notice, my little minions here have already made an internally defined CAM part, and here are all my tool paths. So they've drilled 1, 2, 3, 4, 5 different drill tool paths here. Then they made a pocket and some other things here. So if you wanted to look at this, you could highlight all these things, rebuild them, and then we could calculate them. Oops. And then we could simulate them. So if you go to solid verify, your stuff should look something like this. Notice we can see the pecs now. what did they have to select to get those PECs? It was that step down feature. So they wanted to see the PECs, so they selected that step down. If you don't select it, it'll just go straight through. Why do you suppose they give you the option of seeing those PECs? Right. If you have 500 holes with 20 PECs each, you don't want to sit there and watch that thing all day long. All right. So they pecked it. You should look something similar to this. Okay, there's all the drills. I sped it up. And there's the milling. They went around the side of the plate. Why are they doing just these two sides? Clamps. Then they did these two sides. All right, so a little bit of cheating there. Now, I'm going to show you one other thing. You don't have to use the CNCs to drill these last two parts, two holes. But let's say you wanted to, okay? More likely what you should do for efficiency in our case is take this plate to the manual milling machine and set it in a vise, clamped up like this, clamped in the vise here, edge find here, edge find here, then you'll have a 0, 0 up here, and then you can drill those holes manually. There's only two of them. However, let's say you had the CNC and it had a vise on there and you wanted to do that. You could do that. The way you need to do that, the problem is this coordinate system they defined is based off this face. We need a coordinate system based off this face. So we have to add a coordinate system. Okay? So we go to our coordinate system manager, and instead of editing, we're going to add one. All right? The same rules apply. I'm going to select this face. I'm going to pick my origin. And in this case, I like this one. X is aligned with this axis. Y is aligned with this axis. Z is normal to my face. I like that one. I like my tool start level, my clearance level. Notice that my part lower level is now 6 3/4 because that's how long this piece is. I'm going to hit OK with that. And there it is. Okay, now I have two coordinate systems. I've got the first one I wrote, 1, and I've got this one, Mac 2, 1 up here. Now, if I want to go to operations, I can add a milling operation drill, but I want to pick my other work coordinate system. Does that make sense? Now I have a drop down with two of them. And then I can go through and write this tool path again. Let's go ahead and do it just for a refresher. I can click this hole, put a point there, click this hole, put a point there. I'm done with my geometry. I move to my tool. I select. I need a tool here. What size are these holes? You guys know this. What kind of hole is that? It's a tapped hole for a 440 screw. So I need to go to a drill and tap chart and select the appropriate tap drill for a 440. I know that to be a number 43 drill bit. So I could select that in here. I bet these cats have it in here. It's this one. It's 0.089 is a number 43. So since they already have it in here, I could just select it. Okay. Select. Maybe I should have made sure about my feeds. My feed in Z, that's pretty slow. I'm going to go faster than that. I do like my spindle speed though. And I have coolant. I like that. Okay, now my tool's done. Levels. I'm okay with these clearance and safety distance. How deep do I want to go? Well, you got to go to that 440 tapped hole and figure out how deep it is. I could edit the feature. and it looks like it's a 1/2 inch deep. Okay, I'm cool with that. I go back to this solid cam. It says, what are you doing, dude? And do you want to resume? Yes, I want to resume. So now I've got a 1/2 inch deep. Do you see the power of having solid cam embedded within SolidWorks? Now you don't have to switch back and forth to a bunch of different programs. In this case, I do not care about the full diameter. I'm not going through. So I'm going to just go ahead and leave it as cutter tip. Technology. I better use a PEC drill in this cycle because I'm going a 1/2 inch deep with a very small diameter drill bit. If I try and go all the way down in there, it's going to break. There's no way. So I better select a G83, go to my data. I'm going to set my PEC distance. It's a small drill bit. I'm going to call it 20 thousandths. I don't want this thing to break way down deep in that hole. And I don't want to watch that 20 thousandths a 1/2 inch deep. That's a lot of PECs. So I'm going to leave that 0. I'm going to hit OK, save and calculate. And I'm going to go ahead and simulate. Didn't show me the PECs, just jammed it in there. Solid verify. Notice my solid verify it's got all my tool paths that have already been done. So now I can see what this thing looks like. The only one it doesn't have is this drill path we're about to do. Something bad happened. What's going on here? Yeah, so check it out. It's starting up here. So let's stop that. Let's see. Save and calculate. And then let's see if we can just simulate this one. Okay, we did that. Solid verify. Now we've got just this one. Alright, and it did not show me the PECs, but there it is. And if you twist it a bit, you ought to be able to see, say, about a 1/2 inch deep. And it doesn't look like a circle because of my graphics card. There, it's about a 1/2 inch deep. Okay, make sense? Alright, one last thing I'm going to show you. One last parameter. And this is more for profiling and pocketing, but I want to show it to you anyway because we have a little bit of time. If I go back to when they cut out the two sides. So if I simulate this, there's those two sides, and then I simulate these two sides. This tool path here. Notice that they're the same tool number, tool 5. If I don't do anything and put a separation in between tool 5 and tool 5, it's going to cut these two sides, and it's going to go immediately to these other two sides and start cutting that. What's bad about that? There's clamps in the way. So what we'd like to do is, after this tool path is done, we'd like the machine to stop and give us time to move the clamps. You can do that by editing this tool path and going to miscellaneous parameters, parameters list. Oh, I freaked it out. Parameters list, and if you go to stop and change that to a yes, it will stop for you. You can even write in a message, dummy, move clamps, and it'll show up on the controller. But you want this toggle switch to be on yes, and then it'll stop. Question?
Does it stop before or after the part?
It stops after this tool path and before this one. Questions there? All right. Homework 14, which is assigned today and due tomorrow, I want you to create drilling tool paths. So these drilling tool paths and this one that I just did for this part, for your part. If you want to, you can even go drill your holes. You are now clamped on there. You have seen enough. You've been able to set part zeros, set tool zeros, and did you even run a path or no? Didn't run a path, but you're close. If you want to, with our help, you can go ahead and even run some holes on the machine. But what I want to see is the tool paths written and uploaded to D2L.
Is that individually or by group?
On D2L, it says I'll tell